Welcome to Geometry, Chapter 3, Section 3, Proving Lines Parallel. So yesterday we were talking about parallel lines. Today we're going to use a bit of what we learned yesterday to prove that lines are parallel. So to warm up, pause the video, see if you can write the converse of each statement, and come on back and we'll go walk through it together. Okay, welcome back. We have if A equals B, then A plus C equals B plus C. The converse then would be, yep, if A plus C equals B plus C, then A equals B. Very good. Okay, how about the next one? If the measurement of A plus the measurement of B is 90, then angle A and angle B are complementary. So the converse would be, if angle A and angle B are complementary, then the measure of angle A plus the measure of angle B equals 90 degrees. And finally, the converse would be, if A, B, and C are collinear, then AB plus BC equals AC. Very good. Okay, let's move forward. Our objective today is to use the angles formed by a transversal to prove that two lines are parallel. Using the angles formed, we're going to prove lines parallel. Okay, yesterday we learned that if two coplanar lines are parallel and we cut them with a transversal, we form all these wonderful pairs of corresponding angles, alternate exterior angles, alternate interior angles, and so on. So now we learn that if two coplanar lines are cut by a transversal and we end up with corresponding angles that are congruent, then the two lines are parallel. Very good. So you can see how this is the converse of yesterday's working with parallel lines. Use the converse of the corresponding angles postulate and the given information to show that line L is parallel to line M. So we're given that angle 4 is congruent to angle 8. So this is different than being given the information that L and M are parallel. We don't know that they're parallel, so we're just given that angle 4 is congruent to angle 8. So if angle 4 is congruent to angle 8, we can say that 4 and 8, how are they related to one another with respect to the transversal? Those angles are, you got it, corresponding angles, right? They're corresponding angles. And because 4 and 8 are congruent, and they're in the same orientation in these sets of 4 angles that are created by the transversal, we then can say that line L and line M are parallel. This says line L is parallel to M, and that is the converse of the corresponding angles postulate. Let's try this using the converse of the corresponding angles postulate and the given information to show that line L is parallel to line M. So now we're given something different. We're given that measure of angle 3 is 4x minus 80. Here's angle 3. And measure of angle 7 is 3x minus 50. And here's angle 7. 3 and 7. So what can you say about angles 3 and 7 once again? Yeah, angles 3 and 7 look to be corresponding angles given this transversal cutting through lines L and M. So the interesting other fact we're given is that x equals 30, which of course is something that we can plug in to the given expressions for the measures of these angles. So that's the first thing that's done. So for angle 3, we can plug it in, 30 degrees into this, and we end up with 120 minus 80, which is 40. So we can say that the measure of angle 30 is 40. We can also do the same for measure of angle 7. We can plug 30 in to that one, and here it is here. Wow, they wrote 8 here. This should be 7, right? This should be the measure of angle 7, not 8. Interesting error by the publisher. Anyway, they plug in 30, and it should, this is the expression that we were given for angle 7, and we do have the value of 40 again. Good. So now we can say that the measure of angle 3 and the measure of angle 7, this should say 7, are equal. It's so interesting that they made that error, isn't it? And that is the transition property of equality. And so we can then say that angles 3 and 7 are congruent, and that is the definition, right, of congruent angles, right here. And therefore, because these are in corresponding positions, given the transversal, we can say that line L and line M are parallel. And that's the converse of the corresponding angles postulate. Okay, you don't need to draw this one in your notes. We'll just walk through this together. This is like the last one. The difference is we're actually told that the measure of angle 1 equals the measure of angle 3. Measure of angle 1 equals the measure of angle 3. And so what can we say about these two angles? Well, if their measures equal each other, we can say that these angles are congruent, right? They have the same number of degrees, and that is the definition of congruent angles. They have the same measure. And then we can say they are in the same orientation. They're corresponding angles, right? So we can say that because they are corresponding angles and they are congruent, and line L is parallel to line M given the converse of the corresponding angles postulate. Here's another postulate, the parallel postulate. The parallel postulate tells us that through a point P, not on line L, there is exactly one line that would be parallel to line L. So through any given point that's not on a line, there would be exactly one line that we could draw through that point that would be parallel to the given line. So for proving lines parallel, we can examine the angles that are created by the transversal crossing any two lines. And if we find that that transversal gives us alternate interior angles that are congruent, like this here, angle 1 and angle 2, then we can prove that lines M and N are parallel. Also, we can use the converse of the alternate exterior angles theorem. So we can look at exterior angles formed. These are alternate exterior angles that are congruent. So M is parallel to N. And finally, we have the converse of the same side interior angles theorem. So the same side interior angles are not congruent. They are, however, supplementary angles. So if we have same side interior angles, sum of 180 degrees, line M is parallel to line N. Lots of wonderful options in proving that lines are parallel. Here's a sample to jot down, and in this sample we are trying to prove that R is parallel to S. We're given that measure of angle 4 equals the measure of angle 8. 4 and 8. So if the measure of 4 equals the measure of 8, we know that these are congruent, right? 4 is congruent to 8, and that is the definition of congruent angles. So we can then say, how are these configured based on this transversal cutting through line R and S? And these are, you guessed it, these are alternate exterior angles, aren't they? Alternate exterior angles, and they are congruent. So we've got congruent alternate exterior angles, which proves that line R and line S are parallel given the converse of the alternate exterior angles theorem. Good job. Okay, you don't need to write this one. Let's walk through it. We're trying to prove that R is parallel to S. This time we're given the measure of angle 3 equals 2x, and the measure of angle 7 is x plus 50. And then we are given the value of x, so this seems so easy. Given that value, we can substitute 50 for x, and so the measure of angle 3 equals, what does it equal? 100 degrees. Good. And when we plug 50 in to the expression for the measure of angle 7, 50 plus 50 is 100 as well. So again, that's substituting a known value into the expression, because measure of angle 3 ends up equal to the measure of angle 7, we can then say that those two angles, 3 and 7, are congruent, right? And because they are congruent, we then can say, based on what? The converse of which theorem? Alternate interior angles, right? We can say, based on the converse of the alternate interior angles, that lines R and S are parallel. Why don't you take down this and let's try to prove that line L is parallel to line M. We're trying to prove that L and M are parallel given that line P is parallel to line R. That's a given, and that angle 1 is congruent to angle 3. So the first thing we have is P is parallel to R, which is given. Because P is parallel to R, we can take a look at the two angles that are formed between P and R by this transversal M. What was the relationship between angle 2 and angle 3? Well, we can say they are congruent angles, right? Angle 3 and angle 2, because they are alternate exterior angles. Good. Alternate exterior angles. And then we also know that angle 1 and angle 3 are congruent. That's given. Angle 1 and angle 3 was given. And so look at this. We're trying to prove that L and M are parallel. So given these two lines, we can substitute, right? We can say that angle 1 is congruent to angle 2 by substituting 2 into line 3 based on line 2. So that's substitute, or actually that's transitive. If 1 is congruent to 3 and 3 is congruent to 2, then 1 is congruent to 2. So transitive property of congruency, right? And so if we know that 1 and 2 are congruent, these two angles are formed, they are related to one another as corresponding angles based on the transversal P, aren't they? Here's a transversal P cutting across. They're in the same relative position of angles created by that transversal. So L and M are parallel based on converse of the corresponding angles postulate. Very good. Okay, so as a quick quiz, how about if you could see if you can name the postulate or theorem that proves that line P is parallel to line R. Okay, so if angle 4 is congruent to 5, 4 and 5, can you name it? Good. The converse of the alternate interior angles theorem would prove that P is parallel to R. If we knew that 2 was congruent to angle 7, 2 and 7, that would be the converse of alternate exterior angles theorem. Good. And 3 and 7, angles 3 and 7, how are they related? That would prove that P and R are parallel based on the converse of the corresponding angles postulate. And 3 and 5 would be the converse of the same side interior angles theorem, which tells us that same side interior angles 180 degrees. They're supplementary. Good. Okay, and the final little quick quiz is, can you prove that P is parallel to R given this information? So, if we have angle 2, we need a picture, don't we? I don't see a diagram here. Is there a diagram on the previous one? There it is here. We're going to use the same diagram that you see here. And so we're looking at angles 2 and 7. Let's go back and look at angles 2 and 7. 2 and 7, they appear to be alternate exterior angles. Good. So if we know that angle 2 is 5x plus 20, and angle 7 is 7x plus 8, and we're given the value of x, when we're given a value for x, the first thing we do is plug it in, right? Stick it in there. And when we do, we can find the measure of angle 2. Plug in 6, 30 plus 20, and we have 50. Plug in 6 here, 42 plus 8, and we have 50. So now we can say that the measure of angle 2 equals the measure of angle 7, so these two angles are